Welcome to GATE class. Let us solve this problem. So the fs is given, and that is the Laplace transform of ft, and it is given as k divided by s plus 1 s square plus 4. So fs is given, and we have to find out the final value. So we have to find out limit t tends to infinity ft, that we need to find out. So the solution of this problem is fs is provided, and it is equals to k divided by s plus 1 s square plus 4. And since if we check the pole 0 location, then what we are going to find out that first we need to check the stability, whether the system is stable or not. And the system is stable or not, it can be find out by using the location of poles. So the poles are s is equals to -1, s is equals to plus minus j2. These are poles. So s is equals to -1, there is a pole, and there is a pole at j2, and another pole at minus j2. This is sigma, this is j omega. Now if we see the pole 0 location, then we can say that poles are basically in this system. This system is unstable. So why the system is unstable? So because the system is unstable, because all the poles are not in left hand side of S plane. So all the poles are not lying in left hand side of S plane. So we can easily say that the system is unstable. So basically the system is unstable, so that this final value, that is f infinity, it is undefined. So it is undefined because this system is unstable. So we can't find out the final value of this system, of this problem. So let us do another problem. So the problem is the response of an arbitrary arbitrary initially relaxed system. So the system is initially relaxed, means the all initial conditions are 0. We are assuming initially relaxed system, and the system is linear constant coefficient. Basically impulse response. So the response of an initially relaxed system to a unit impulse input at t equals to 0 is 4 e raised to the power minus 2t into ut. So basically that yt is given. So yt is 4 e raised to the power minus 2t into ut, and this is we are getting this response we are getting when our input is unit impulse. So what we need to find out? So find out, the question is find out find out the response of the network, find out the response of the network to a find out the response of the network to a unit step function, So for this type of problem, first we can let us understand what the problem is saying. And this is very simple problem, but if you understand the problem, then it is very simple. So the problem is what is the LTI system? We have xt, and this is the output yt and the impulse response st. So when xt is del t, when we are applying xt is equals to del t, then the output, that response, is nothing but the impulse response. And the impulse response of the system is given. It is 4 e raised to the power minus 2t into ut. So this is the response when we are providing del t, that is impulse function. So now the question is saying that now if we are providing step function, so instead of impulse we are providing a step function, then what should be the response? What should be the response to the same LTI system with impulse response st? If we providing the input ut, then what should be the response? So from the first part of the question, we understand that the system function can be calculated as 4 divided by s plus 2. So this is the system function. This is the system function. So our first aim is to find out the system function. When we are going to do this type of problem, our first aim is to find out the system function. Now the next step is the system function is related with output and input by this relation. So we have ys is xs multiplied by hs. Now the input xt is ut, then xs is nothing but 1 divided by s, so it is equals to 1 divided by s into hs. So ys is equals to 1 divided by s multiplied by 4 divided by s plus 2, so it is equals to 4 divided by s plus 2. So this is our response when we are applying the input as unit step. So we can solve it by using the partial fraction analysis. So it is equals to a divided by s plus b divided by s plus 2. So what is a? So a is s multiplied by ys for s is equals to 0. So it is 4 divided by s plus 2 for s is equals to 0. So it is equals to 4 divided by 2, that is 2. And b is equals to s plus 2 multiplied by 4 ss plus 2 when s is equals to minus 2. So it is 4 divided by minus 2, that is equals to minus 2. So the solution of this problem, so if we find out that what is ys, we can put the value of a and b here. We will find out the value of ys. So the after putting the value of a and b, what we are getting, ys is equals to 2 divided by s minus 2 divided by s plus 2. So yt is nothing but 2 ut minus 2 e raised to the power minus 2t into ut, and we can take 2 and ut common. So 2 1 minus e raised to the power minus 2t into ut. This is yt. This is yt. So yt is equals to 2 1 minus e raised to the power minus 2t into ut. This is yt. So let us start the jet transform. So let us start the jet transform. So this basically the Z transform is introduced to represent the discrete time signal. So basically the Z transform is introduced to represent the discrete time, signals. And also we can say because it is in the form of impulses function, so it is sequences we can say. So in the Z domain, signals in Z domain. So what is Z? And Z is a complex variable. So basically the concept of system for a discrete time LTI, system will be described by this Z transform So the Laplace transform converts the integral differential equation into algebraic equations. So if we compare it with the Laplace transform, so the Laplace transform, what Laplace transform is doing, the Laplace transform converts the integral differential equations into algebraic equations. So the same thing is that this is a counterpart, this is Laplace Z transform is basically the counterpart of the discrete time Laplace transform, which is we have analyzed in discrete time system. So the properties of Z transform closely parallel those of the Laplace transform. However, we will see important distinction. Between the Z transform and the Laplace transform. So let us discuss the definition of Z transform. Let us start by what is the definition of Z transform. So we saw that for a discrete time LTI system with impulse response Hn, so for a discrete time LTI system with the impulse response Hn, the output Yn of the system to the complex exponential input is related with, so the output Yn, so when we are applying inside the system operator this complex exponential input z raised to the power n, then it is equals to Sz multiplied by z raised to the power n. So this is our basic definition for any discrete time LTI system. So what is Hz? So where Hz is equals to summation n is equals to minus infinity to plus infinity hn z raised to the power minus n. So this is hz. So the definition, we can derive the definition from this result. So we can derive the definition from this result. So the function hz, in equation 2, the function hz in equation 2 is referred to as the z transform of hn, So for a so if we consider a general scenario, so for a general sequence or signal xn, the z transform is given as xz is equals to summation n is equals to minus infinity to plus infinity xn z raised to the power minus n. So the variable z is basically, the variable z is generally complex valued, and it is expressed in pole zero form, and it can be expressed in pole zero form. So it can be written as z is equals to r e raised to the power j omega. So it can be represented in the form of pole zero form. So where the variable z is generally complex valued, and it is represented in pole zero form, is generally complex valued, but the variable z may be real also, because sometimes that in real part is there, or imaginary part sometimes may be zero, that is, but generally it is complex valued. So what is r? So r is basically the magnitude of z. The r is magnitude of z. We can prove that here. So z is r e raised to the power j omega. So mod z is equals to modulus of r e raised to the power j omega, and that is simply equals to r. So r is basically the magnitude of z, or the absolute value of z. And what is phi? What is omega? So omega is angle of z. So phi, r is magnitude of complex valued signal z, and omega is that phase angle, that angle of z. So the z transform is what we have considered. We have considered xz is equals to summation n is equals to minus infinity to plus infinity xn z raised to the power minus n. So this is basically the bilateral z transform. This is basically the bilateral z transform. And there is unilateral z transform also there. So there is unilateral z transform. And the unilateral z transform, let it is represented by x1z, and that is equals to summation n is equals to 0 to infinity xn z raised to the power minus n. So closely the bilateral and the unilateral z transforms are equal only if xn is equals to 0 for n less than 0. So when we have condition that xn is equals to 0 for n less than 0. When we have this type of condition, when we have xn is equals to 0 for n less than 0, so closely the bilateral and unilateral Z transform will be equal. So when we have this condition, that is xn is equals to 0 for n less than 0, then the bilateral and the unilateral Z transform will become equal. The unilateral and bilateral Z transform will become equal. So let us do some problems related to Z transform, some basic problems. So xn is given as a raised to the power n un, and what is a? So a is basically the real number. Now we can find out the Z transform of this signal. So it is xz. So the definition of Z transform is xz summation n is equals to minus infinity to n is equals to plus infinity xn z raised to the power minus n. So it is equals to summation n is equals to 0 to infinity a raised to the power n z raised to the power minus n. So why this comes? Because un is 1 for n greater than or equal to 0, and it is 0 for n less than 0. So that's why from minus infinity to 0, that value is 0, and from n is equals to 0 to infinity, it is a raised to the power n z raised to the power minus n. So it is summation n is equals to 0 to infinity a z inverse raised to the power n. Now if we analyze this equation, equation, we can find out that this for the convergence of this series. So what we can analyze that for the convergence of series, the condition should be modulus of a z inverse should be less than 1. So basically mod z should be greater than mod a. So this is the condition for reason of convergence. And the solution of this is basically 1 divided by 1 minus a z inverse. Please check. And the ROC is mod z greater than mod a. So this is the condition for reason of convergence, and this is the Z transform. Now we can find out that this is not but it is equals to Z divided by Z minus a. So this is equals to Z divided by Z minus a. So the zeros, basically the poles are, so the poles are Z is equals to a, and 0 is Z is equals to 0. So that ROC is mod Z greater than modulus of a. Now we have two conditions. The first condition, when we have mod Z greater than mod a and the a is greater than 1. This is the first condition. So let us draw the ROC. So a greater than 1. So there is a unit circle. That is 1 and of radius 1. Then we have another circle. Of radius a. and a is greater than 1. That's why we have plot, that's why we have taken a greater than 1. That's why this type of plot is coming. So now what is the ROC? The ROC is mod z greater than a. It means it is exterior to this circle. It is exterior to this circle. So this is z plane, this is z plane. So the ROC is the ROC is exterior to A, means mod z greater than mod A, means it is exterior to this outer circle, that is mod z is equals to A. So this represents equation of circle. So it is exterior of the circle. So what is happening, that a very important conclusion is that since the ROC does not include the unit circle, since the ROC does not include the unit circle, so system is unstable. System is unstable. So what is the condition of stability? The ROC should include the unit circle. ROC should include the unit circle for condition of stability. For the case when a is greater than 1, this is not happening. Now we can see the second condition. So the second condition is modulus of z greater than modulus of a and a less than 1. So the second condition is a less than 1. So we have mod z greater than mod a. It means we have unit circle. That should be bigger circle. That should be bigger circle, because that modulus of z is greater than a and a is less than 1. So this is a. So this is unity circle. Now the ROC is basically mod z greater than a. Then So the ROC is modulus of z greater than a and a is less than 1. So this is our ROC. This is our ROC. Now we can easily see that this ROC contains the unit circle. The ROC contains the unit circle. So since the ROC is containing the unit circle, because the ROC is containing the unit circle, so we can easily say that the system is stable. So since the ROC is containing the unit circle, so system is stable. So system is stable. So it is a stable system because the ROC is containing the unit circle. Okay. So this is our second condition. Let us do another problem. So the previous problem is related to causal signal. Now we are going to see the analysis of that transform by using a non-causal signal, that is left-handed signal basically. So we have xn, that is equals to minus a raised to the power n u minus n minus 1. So the z transform, we need to find out the z transform, and a is real. A is real. So what is xz? So xz is summation n is equals to minus infinity to plus infinity xn z raised to the power minus n, and that is equals to n is equals to minus infinity to minus 1 only, minus a raised to the power n into 1 into z raised to the power minus n, plus n is equals to 0 to infinity, it is 0 only. because that u minus n minus 1 is equals to 1 for n less than or equal to minus 1, and it is 0 for n greater than minus 1. So for n greater than minus 1 it is 0, and between minus infinity to minus 1 the value is 1. So xz is basically, it is from n is equals to minus infinity to n is equals to minus 1 minus a raised to the power n z raised to the power minus n, and that is equals to summation n is equals to minus infinity to minus 1 minus a z raised to the power minus 1 n. So this is our z transform. This is our z transform. Now we need to solve this series. So what we can do, we can replace m is equals to minus n. So what we will get? We will get xz, that is equals to m is equals to infinity to m is equals to 1, and that is equals to az raised to the power minus 1, and here we can write minus m. So further it can written as m is equals to 1 to m is equals to infinity. There is no harm to interchange these two limits, and because this is a summation, there is no harm. If we have a continuous time integration, then we have to put minus sign when we are going to change the upper and lower limit, and here we have to put a inverse z. So we can write in this manner, so this is xz. Now we need to find out the convergence for this series. So the convergence for this series, this term for the convergence of this series, modulus of a inverse z should be greater than 0 or less than 0. Yes, of course it should be less than 1. It should be less than 1, not 0. It should be less than 1. So if this condition is met, then we can say that the series will converge, otherwise the series will diverge. The series will going to diverge. So basically it means that mod z should be less than modulus of a. So this is the reason of convergence. And the solution of this is, again, please check, we will get 1 divided by 1 minus az inverse. So the solution of this problem is, the z transform is 1 divided by 1 minus az inverse, and the ROC is modulus of z less than modulus of a. Now we have again two conditions. We have again various cases. So the first case is when a is less than 1. So when a is less than 1, when the magnitude of a is less than 1, then we have the ROC. We plot the ROC, then that there is a unit circle. So this is the unit circle, and since a is less than 1, so a is somewhere inside this circle is that modulus of z is equals to modulus of a. Circle is inside the unit circle somewhere here with radius a, because a is less than 1. Now what should be the ROC? So the ROC is given that it is modulus of z less than a. So this is the interior of this. So this is the ROC. This is the reason of convergence. So it is interior. So what are the important conclusions we have? So we have conclusion is that the ROC is interior. The ROC is interior of the circle. Modulus of z is equals to modulus of a, and also the ROC does not include the unit circle. So it means the system is unstable. The system is unstable. So for a is less than 1, the system is going to be unstable. Now let us take the second case. So the second case is a greater than 1. So a greater than 1, so we have the unit circle, we have this unit circle, and since it is a is greater than 1, so we have another circle, and this is a, this is a, and the ROC is modulus of z greater than modulus of a. So the ROC is this part is the ROC. So since this is the this ROC is basically sorry, we have some mistake. It is causal signal. So this modulus of z. So again, I am redrawing this. So that this is modulus of z less than modulus of a, the ROC should be inside the unit circle. So this is the unit circle inside the unit circle. So this is the ROC, that is the important points we have. The ROC includes the unit circle. The ROC includes the unit circle. The second important point is that since the ROC is including the unit circle, so the system is stable for a greater than 1. So when we have a greater than 1, the system will be stable, otherwise the system is unstable. So this is our important conclusion, and one of the most important conclusion is that since xn is equal to a raised to the power n u n, and the z trans and a is belongs to real, the z transform is xz, that is equals to 1 divided by 1 minus a z inverse, and the ROC is real part of ROC is modulus of z greater than modulus of a, and for if we consider xn is equals to minus a raised to the power n u minus n minus 1, then the z transform is also 1 divided by 1 minus a z inverse, and the ROC is modulus of z less than modulus of a. So if we compare these two z transforms, then the z transform is same. So what is the important conclusion is that the z transform for a raised to the power n u n and minus a raised to the power n u minus 1 will be same, but the z transform for these two signals will be same, but since one is causal and one is non-causal signal, so it depends upon the ROC. So it depends, but it depends upon the ROC. It depends upon the ROC whether the signal is causal or not, whether the signal is causal or not. So since it is a causal signal, so the ROC is modulus of z greater than modulus of a, that is exterior to the circle, that is exterior to the circle. And since this is a non-causal signal and the ROC is basically modulus of z less than a, so it is interior to the circle, so it is interior to the circle. So here we have a, and it is exterior to the circle, and here we have A, and it is interior to the circle. So that ROC of causal signal is basically exterior. It always go exterior to the circle, and that causal for non-causal signal, it will always go interior to the circle for if it is a non-causal signal. But if we see that the Z transform for both these signals are same, so only finding out the Z transform is not the complete solution. The complete solution is that you have Z transform as well as the ROC should be defined, because the ROC will define which type of signal it is. It is causal signal, maybe it is non-causal signal. So all those things are there. So we have to define the ROC properly. Let us discuss the various properties of ROC. So let us discuss the properties of ROC. Properties of region of convergence. So the first property is the ROC will not contain any pole. So the ROC does not contain any pole. The ROC does not contains any pole. So the second, so if we consider this relation, that is xz is equals to 1 divided by 1 minus az inverse, and the ROC is modulus of z greater than modulus of a. So if we plot the ROC, then what we will get here, we have a here, and this ROC is modulus of z greater than a, that is exterior to this circle, that is exterior to this circle. So basically this ROC is not containing any pole. So the ROC will not contain any pole. So what is happening that if the ROC will contain the pole, so what is happening that the xz is z divided by z minus a. So at z is equals to a, we can see that xz is undefined. The xz is undefined. It is so basically we mean that if the we should avoid the pole in the ROC. We should avoid the pole in the ROC, because at the pole the function will become undefined. Second property is if xn is a finite sequence signal, if xn is a finite sequence signal, so basically the xn is defined, xn is equals to 0 except in a finite interval, So except in a finite interval, so xn is not equals to 0 when we have n1 is less than n is less than or equal to n2. So between n1 and n2 it is equals to, not equals to 0, and it is equals to 0 when we have the interval that is outside this interval. So outside this interval xn is 0. So what is n1 and n2? So where n1 and n2 are finite values, where n1 and n2 are finite values, and xz converges for all values of z, and xz converges for all values of z if xz converges for all values of z, then what is the ROC? Then the ROC is entire z plane. The ROC is entire z plane except z is equals to 0 or z is equals to infinity. So that xz is basically it is defined for entire z plane except when we have z is equals to 0 or z is equals to infinity. So let us take an example. So if we have xn that is finite, so it is 1 2 1 4 5 1. So suppose this is the signal and there is an arrow, so this arrow indicates that it is n is equals to 0. So what is z transform for that? So z transform, if we calculate, that is equals to summation n is equals to minus infinity to plus infinity xn z raised to the power minus n. So it is x0 z raised to the power minus 0 plus x1 z raised to the power minus 1. So for this it is n is equals to minus 1. So it is n is equals to minus 2. It is n is equals to minus 3. It is n is equals to 1 and it is n is equals to 2. So we can go up to x2 z raised to the power minus 2 and x3 z raised to the power minus 3. And similarly, negative side we can go from z raised to the power 1 x1 plus x2 z raised to the power 2. And rest of the terms are 0. Rest of the terms are 0. So we can see here that the value of x0 is 1. So we have 1 plus 1 plus 4 z inverse plus 5 z raised to the power minus 2 plus z raised to the power minus 3 plus 2 z raised to the power 1 plus z raised to the power 2. Now this is xz. So if we analyze this expression, then at z is equals to 0, xz tends to infinity, and at z is equals to infinity, xz tends to infinity also. So this negative powers will provide unbounded result when z is equals to 0. So these negative powers are providing unbounded result when z is equals to 0, and these positive powers will provide the unbounded result when we have z is equals to infinity. So the ROC is entire z plane. ROC is entire z plane except z is equals to 0 and z is equals to infinity. Next property is if xn is right-sided signal. If xn is right-sided signal, that is xn is equals to 0 for what values of n? For when small n is less than capital N infinity, comma, and capital N is less than infinity. So this small n should be less than capital N and that capital N should be less than infinity. If xn is 0, for this case xn is 0, then it is a right-sided signal. So it is a right-sided signal. For example, un. So un is a right-sided signal. So un is equals to 1 when we have n greater than or equal to 0, and it is equals to 0 when we have n less than 0. It means for n, it means that xn, if xn is un, then it is 0 for when we have n less than capital N less than infinity. So for all values of n that is less than 0, this un is 0. That's why it is simply a right-sided signal. So if the condition is satisfied, then this is right-sided signal. So if xn is a right-sided signal and if xn is a right-sided signal and xz converges for some value of some value of z, then the ROC is of the form, then the ROC can be represented in this form, and it is represented as that modulus of z is greater than R max. Modulus of z is greater than R max, or it can be also written as infinite is greater than modulus of z, and that is greater than R max. So when R max equals the largest, what is R max? So basically that R max, so where the R max is the largest magnitude, the R max is the largest magnitude of any poles of xz. So the pole, what we find out the magnitude of the pole, and that is the largest pole. That is the largest magnitude of that means of the pole, largest magnitude present in the present in xz of all the poles. So thus the ROC is the exterior of the circle. So what is the catch here? The ROC is basically the ROC is exterior of the circle. So we can see in our problem that we have considered. So when we have xn is equals to a raised to the power un, then the xz is nothing but it is equals to 1 divided by 1 minus az inverse, and the ROC is modulus of z greater than modulus of a. So this is a, and the ROC is exterior to this circle. The ROC is exterior. So ROC is exterior of the circle. Modulus of z is equals to modulus of a. So it is basically exterior of the circle. So it depends on the value of a whether the ROC will include the unit circle or not. It depends on the value of a. So if a is greater than 1, then of course it will not include the unit circle. But if a is less than 1, then this will include the ROC will include the unit circle. So the ROC is basically, so we can say that there is a conclusion. Thus the ROC is exterior of the circle. So the ROC is exterior of circle, and so exterior of circle means suppose we have the poles, we have many poles are there, means not single pole, many poles are there. So we will calculate the R max, suppose the signal is not like just like this signal. We have some other it is a mixture of some signals. So we will calculate the numbers. Here we have only one pole, so here we have only one pole, that is z is equals to a. So if we have poles like z is equals to a, 2a, 3a, then the maximum is maximum magnitude we will calculate, that is r maximum. So modulus of z should be equals to r maximum. That modulus of z should be equals to r maximum, and that ROC is exterior to that circle. So the ROC is exterior to that circle. So the ROC will be exterior to the circle. Modulus of z is equals to r maximum. Modulus of z is equals to r maximum. So the ROC is exterior to this circle. That is modulus of z is equals to r maximum, exterior to that. So we have a circle of radius, that maximum radius is r maximum. So that ROC is outer to this. So suppose we have this type of signal. Suppose we have signal xn is equals to, suppose we have signal xn is equals to x1n plus x2n plus x3n, and the ROC of this is basically the ROC of this signal is modulus of z is greater than 1, and for the ROC of this is modulus of z greater than 2, and the ROC of this is modulus of z greater than 3. Then if we plot, if we just find out the common ROC, then we can find out that this is 1, this is 2, this is 3. So that common ROC is basically, this is the common ROC, this is the common ROC, this is the common ROC. So the common ROC is modulus of z greater than 3, and 3 is basically the R maximum is equals to 3. The R maximum is equals to 3. So that ROC is, common ROC is modulus of z is equals to R maximum greater than R maximum, that is equals to 3. So it is the maximum magnitude of the pole that is presented, that is present for this system, that is x3, and that is modulus of z greater than 3. So the maximum pole magnitude is 3, so that ROC is modulus of z greater than R maximum, and that is equal to 3. So now if we consider a left-sided sequence, so if xn is left-sided sequence, if xn is left-sided sequence, so if xn is left-sided sequence, that is xn is equals to 0 for n is greater than n2 and greater than minus infinity, and xz converges for some value of z, then the ROC is of the form, modulus of z is less than R minimum. Modulus of z is less than R minimum, or 0 is less than modulus of z is less than R minimum. So what is R minimum? So where R minimum is the smallest, where the R minimum is the smallest magnitude of any of the pole of xz, thus the ROC is the ROC is the interior. Please understand this term. The ROC is basically the interior of the circle modulus of Z is equals to R minimum in the Z plane with the possible exception of Z is equals to 0, with the possible exception of Z is equals to 0. So let us take an example. So at xn is equals to minus a raised to the power n u minus n minus 1. Let us take this example. So the ROC is interior to this circle. So this ROC is interior to this circle. So if we have a combination of signals, left-sided signals, this is a combination of 3 signals. Suppose the Z transform of this, the ROC is less than -1, the second ROC is less than -2, and the third ROC is less than -3. Then what should be the common ROC? So let us draw the common ROC. So the common ROC should be like this. So we have 3 circles. One for this is for -1, that is modulus of Z is less than means -1. So it is basically it is in the form of modulus, so better to take in the form of modulus. So it is 1, 2 and 3. So this modulus of Z less than 1, modulus of Z less than 2, modulus of Z less than 3. Now we can easily say that the ROC is this one, this part, this is the ROC, this is the ROC. So that R minimum, that is lowest magnitude, is 1. We have poles at -1, we have poles at -2, we have poles at -3. The magnitude is simply modulus of Z less than 1. Second ROC is modulus of Z less than 2. The third ROC is modulus of Z less than 3. So basically the R minimum is 1. So the circle is modulus of Z is equals to R minimum, and the ROC is nothing but it is the interior. So this is the radius R minimum, it is the interior of this circle. Now again it depends on the value of A, whether A is greater than 1 or A is less than 1. Then we can find out we can tell about the stability of the system. So it depends on the value of A. So let us discuss another property that is very important, and this property tells that if Xn is two-sided sequence, then Xz converges and Xz converges for some value of Z, then the ROC is of the form, R1 is less than modulus of Z is less than R2. And what is R1, R2? Where R1 and R2 are the magnitude of the two poles of Xz. So we can say that the ROC is an ring. The ROC is in the form of ring in the Z plane. The ROC is in the form of annular ring. Basically, it is annular ring in the form of annular ring. This type of in the Z plane. So basically, it is between the circles modulus of Z is equals to R1 and modulus of Z is equals to R2, not containing any pole, and it is not containing any pole. That is very important. It is not containing any poles. It is very important. So we have let us take an example. So xn is equals to 1 by 3 raised to the power n un plus 1 by 2 raised to the power n un. So this is x1n and this is x2n. This is xn. Now we can say that ROC is for this is a causal sequence. So it is 1 by 3. Then we have 1 by 2. So this is 1 by 2. Then the ROC is basically if it is a two-sided. So since we have both the causal, so this is not a two-sided signal. Okay, so this is the ROC. So this is not two-sided signal. Now two-sided signal is like this. So this is not two-sided signal. This is not two-sided. So let us I told you this only to just differentiate between two-sided and one-sided. So this is not two-sided. Basically, this is right-sided signal. So this is right-sided signal. This is a right-sided signal. And two-sided example is if one signal is the lower magnitude pole should be causal and the higher magnitude pole should be non-causal. So this is an example of two-sided signal. So this is two-sided signal. Now we can plot the here we have this a circle that is 1 by 3 and another is circle 1 by 2. So since we can say that it is a causal, then the ROC should be outside, and since this is a non-causal, the ROC should be interior. So the ROC should be interior. So it is just like that. It is interior. It is interior to that. So since this will give the ROC, that is modulus of Z is greater than 1 by 3, and this will give the ROC, and this will give the ROC, that is modulus of Z less than 1 by 2. So it is modulus of Z greater than 1 by 3 and it is modulus of Z less than 1 by 2. So we can easily say that this is a two-sided signal, and that we can say that it can be easily seen that the ROC is in the form of ring. So ROC is annular ring. ROC is annular ring form. ROC is in the form of annular ring. You can easily say that from this example.